Have you ever wondered what it feels like to watch the largest twin-engine jet in history lift off the ground? Not just powered by raw thrust, but guided by artificial intelligence. It's not just a machine taking flight. It's the future of aviation unfolding in real time. This isn't another flashy clip of a plane roaring down the runway. What you're about to discover is something deeper, something built on decades of engineering, shaped by precision, and controlled by a level of intelligence that was once only imagined in science fiction. Stay with this video until the end, and you'll not only witness a takeoff like never before, you'll understand what makes it so extraordinary. The final piece will tie everything together, and once you see it, you'll never look at aircraft the same way again. The Boeing 777X is more than a new jet. It's a milestone. Launched to redefine long-haul travel, it combines the reliability of the 777 family with the technological edge of the future. The 777X is the longest and most efficient twin-engine aircraft ever built, measuring over 76 meters from nose to tail. But size is just one part of the story. What truly sets the 777X apart isn't just what you see, it's what you don't. Beneath the surface lies a complex brain, an integrated system that connects software, hardware, sensors, and now, artificial intelligence. This invisible layer is quietly taking control of what used to require constant human input. The jetliner world is undergoing a silent shift. Where pilots once relied solely on manual judgment, now intelligent systems assist, adapt, and learn from every flight. These systems don't just react, they anticipate. They monitor environmental data, system performance, and control responses in real time. And at the core of this evolution is the 777X. For aircraft lovers, this is the kind of transformation that rewrites the rules. Because if you understand the beauty of flight, you also understand the precision it demands. Every second during takeoff is a carefully choreographed balance between lift, drag, weight, and thrust. In the 777X, this balance is refined to levels never seen before. What makes the Boeing 777X takeoff different isn't only the aircraft's physical capability, it's the way it thinks. Through what's known as fly-by-wire technology, the traditional mechanical controls are replaced by an electronic interface. This system translates pilot inputs into digital signals, allowing the aircraft's control computers to make micro-adjustments that humans could never do in real time. But this isn't new. What is new is how artificial intelligence has begun to integrate with these systems, not to replace pilots, but to assist them in ways that boost safety, stability, and efficiency. AI in modern aviation doesn't just help a plane fly, it helps it fly smarter. Imagine a takeoff where the aircraft knows the exact runway condition, current wind profile, engine response characteristics, and weight distribution, and continuously adjusts for them, even as the wheels leave the ground. This level of real-time calibration is now possible, and the 777X is leading the way. Its wingspan stretches to over 71 meters. That's longer than a 747's, but with folding wingtips, controlled by automated systems, it's still airport-friendly. The folding mechanism itself is a marvel, powered by onboard diagnostics that assess and ensure correct locking before every departure. These aren't just mechanical actions, these are decisions, made with support from intelligent monitoring systems that learn and evolve with each flight. The 777X doesn't just fly, it interprets. It gathers data from sensors across the fuselage, wings, and engines. This data feeds into predictive models that adjust control surfaces, monitor vibrations, and anticipate torque shifts. The reward of this intelligence is seen in one of the most stable and precise takeoffs ever captured on camera. When you watch the 777X lift into the air, you're seeing the result of algorithms working in harmony with human control. You're witnessing years of computational modeling, wind tunnel testing, and AI development come together in a single moment. And here's what makes it powerful, not just from a technical standpoint, but a psychological one. Humans crave consistency. Our minds are built to trust patterns. In aviation, this trust is earned through smooth, predictable, and reliable performance. AI-driven systems are delivering that. They reduce uncertainty, they remove error margins. They create a rhythm in the motion, one that feels almost organic. For plane enthusiasts, this touches something deeper. Watching a takeoff isn't just about hearing the engines roar, it's about understanding how every element connects. It's the knowledge that beneath the metal and carbon fiber, there's a living learning system making thousands of choices per second. Also, the aircraft can rise effortlessly into the sky. The Boeing 777X isn't just big, it's intelligent. And that intelligence begins long before the wheels leave the ground. In the next section, we'll uncover exactly how this intelligent system works, the algorithms, the sensors, the control layers, and how they all come together during those critical first seconds of flight. This isn't just about aviation, it's about the evolution of machines that learn to fly. So if you thought you'd seen everything a jetliner could do, you're about to realize we've only just taken off. Every aircraft is built on science, but the 777 times is built on something more, intelligence that adapts. At the heart of its innovation lies a digital nervous system, linking sensors, software, and real-time decision-making. What once relied entirely on human reflex is now supported by a system capable of calculating thousands of variables every second. This begins with fly-by-wire technology, a system that removes the need for direct mechanical linkages between the pilot and the aircraft's control surfaces. Instead, every input is translated into digital signals. These signals travel through onboard computers, which then command the aircraft's ailerons, rudder, elevators, and spoilers. But fly-by-wire on its own is not new. What sets the 777 times apart is how artificial intelligence is layered on top of this foundation. AI algorithms assist in decision-making. They don't just follow instructions, they evaluate conditions. They recognize patterns. They analyze data from previous flights, and they learn. During takeoff, these systems are in constant operation. AI interprets live feedback from the runway, surface texture, friction levels, wind direction, and even micro-vibrations. These are all factored into how the aircraft adjusts its control surfaces in real time. It's not just following a pre-planned path, it's adapting to the exact environment it encounters in that moment. One of the most visible examples of this intelligence is in the aircraft's wings. The 777 times features the longest wingspan ever built for a Boeing commercial jet, over 71 meters wide. To make this massive span compatible with existing airport gates, Boeing designed folding wingtips. The transition between folded and extended positions is completely automated. These wingtips are more than moving parts, they are precision systems. Each movement is verified by AI-supported diagnostics. Sensors confirm wing angle, hinge status, lock integrity, and mechanical resistance. If even the slightest discrepancy is detected, the system alerts the pilots and prevents takeoff until it's resolved. This isn't just convenience, it's safety built into design. Redundancy is key in aviation, and in the 777 times, each major system, flight control, hydraulic, electrical, is layered with backup paths. AI contributes by scanning those redundancies in real time, ensuring that if a single component lags, fails, or produces irregular data, another system takes over instantly. This kind of layered thinking makes the aircraft more than a sum of its parts. It makes it resilient. Nowhere is this more critical than in the aircraft's propulsion system. The Boeing 777 times is powered by the General Electric Genine Times engines, the largest and most fuel-efficient jet engines ever built. Each engine delivers over 100,000 pounds of thrust, but does so with 10% lower fuel burn than its predecessor. AI plays an essential role here. Engine sensors track internal temperature, vibration harmonics, air pressure ratios, and turbine speeds. This data is fed into onboard control units that use predictive algorithms to fine-tune engine performance during takeoff. These systems analyze whether the engine is performing at optimal levels and adjust fuel flow, fan speed, and bypass ratios accordingly, all in real time. The result is more than power, it's precision. Too much thrust wastes fuel and stresses components. Too little compromises safety. AI balances this equation by continuously calculating the exact force required based on current altitude, air density, payload weight, and runway conditions. Beyond the engines, the entire aircraft is wrapped in a network of sensors, more than 50,000 in total. These include accelerometers, gyroscopes, pressure sensors, and GPS receivers. Every sensor feeds into a centralized flight control system. From the first rotation on the runway, AI uses this data to optimize pitch, yaw, and roll. One example is rudder control. During a standard takeoff, pilots must use the rudder to counteract crosswind and engine torque. In the 777 times, AI-enhanced yaw dampers assist in this correction, adjusting pressure on the vertical stabilizer hundreds of times per minute to ensure smooth alignment. Even cabin pressurization and climate control during takeoff are now adjusted by intelligent systems. As altitude changes, AI monitors pressure differentials, temperature drift, and airflow regulation, keeping everything in balance for passenger comfort and aircraft integrity. But perhaps the most sophisticated aspect of the 777X's system is its use of data fusion. This is the process of combining information from multiple sensors and subsystems to produce a single accurate understanding of the aircraft's state. It's how the jet knows exactly how high it is, how fast it's going, and what the environment around it looks like. Not from one sensor, but from a symphony of them working together. This fused data is used by the AI to enhance performance in ways that feel almost predictive. If wind patterns begin to shift at rotation speed, the aircraft adjusts. If runway friction changes due to rain, braking configurations are modified in milliseconds. These adjustments happen without the pilot needing to intervene. This doesn't reduce pilot authority, it enhances it. AI doesn't take control. It acts as a second mind, working alongside the crew, refining inputs, supporting decisions, and making sure that each action taken is the most efficient and safest possible. All of this comes together in the critical seconds when the plane accelerates down the runway and lifts into the sky. What looks like a smooth takeoff is, in truth, the outcome of thousands of calculations. Each one aligned to perfection, each one invisible to the eye. The Boeing 777X isn't just engineered to fly, it's engineered to think. From the moment the Boeing 777X begins to move, everything is calculated. Every sound, every vibration, every reaction beneath the wheels is being recorded, analyzed, and processed by systems built to operate within tolerances narrower than a human breath. Takeoff isn't just a motion, it's a controlled event where technology and physics meet. The sequence begins with pushback from the gate. Even here, aircraft systems begin gathering live data. Brake temperatures, hydraulic pressure, engine readiness, and outside air conditions are all fed into the flight control computers. Once taxi clearance is received, the 777X rolls out, guided by nose-wheel steering, which is electronically controlled and supported by real-time feedback from the gear sensors. Before entering the runway, the crew arms the auto throttle and aligns the aircraft with the center line. At this point, everything is set. But what follows is not just a manual act, it's a coordinated engagement between pilot and machine, with AI overseeing every second that unfolds.
Throttle is advanced to takeoff power.
The twin G9 engines respond instantly, spooling up with a low-frequency roar. But this isn't just thrust. Each engine is under continuous monitoring. Sensors measure pressure at various stages of the compressor, fuel-to-air ratios, turbine temperature, and rotational speeds. AI uses this data to confirm symmetrical output from both engines, automatically correcting for even the slightest imbalance. As the aircraft accelerates, acceleration sensors under the fuselage track longitudinal G-forces. The AI system compares actual acceleration to expected performance, using weight, wind, slope, and temperature as reference variables. If performance deviates, systems alert the flight crew within milliseconds. It's not a reaction, it's a safeguard built on anticipation. The aircraft passes 80 knots. At this point, system checks are still running in parallel. Flight control surfaces like the rudder and ailerons are tested automatically by AI logic for any abnormal feedback or deflection rates. The yaw damper begins subtle corrections to counter engine torque and possible crosswinds, ensuring a straight path down the runway without pilot micro-adjustments. Then comes V1, the decision speed. This is the point of no return. After this moment, takeoff must continue even if there's an engine failure. The calculation of V1 depends on runway length, aircraft weight, engine power, and airfield elevation. All these variables are integrated into the flight management system well before takeoff. What makes the 777X different is how the system adjusts this dynamically if runway conditions shift in real time. Rotation speed, VR, is next. The pilot gently pulls the control column, but the command goes into the flight control computer, which interprets the input. Rather than a direct mechanical link, the digital flight control system determines the best elevator response based on current airspeed, center of gravity, and pitch rate. The result is a smooth, balanced nose-up motion with minimal trim input required. As the nose lifts, sensors under the aircraft measure pitch angle and vertical acceleration. Angle of attack sensors confirm the lifting force matches predicted lift profiles for the flap configuration. If there's any deviation from expected behavior, such as a slower climb or unusual nose attitude, the system cross-checks all sensor inputs and can recommend immediate adjustments through cockpit alerts. At liftoff, the main landing gear leaves the runway. Weight on wheels sensors deactivate, triggering the AI-controlled transition into airborne mode. cabin pressure control adjusts to begin gradual depressurization. The flight control laws now prioritize flight stability, adjusting the responsiveness of control surfaces to ensure a smooth climb even in turbulent conditions. During this phase, the aircraft enters climb out. The autopilot is often engaged within seconds, but even before that, AI is helping stabilize the aircraft's attitude. If gusts or crosswinds are detected, the rudder and ailerons are constantly recalibrated. These aren't big corrections. They're micro movements, dozens every second, creating a feeling of seamless control. As altitude increases, engine performance is continuously optimized. AI monitors outside air temperature and pressure to adjust thrust for the most efficient climb. Thrust reduction points are calculated in real time, not just by a static profile. This saves fuel and reduces engine wear. Landing gear is retracted. The hydraulic system powering the gear is monitored for pressure consistency, and sensors confirm gear door closure. If anything is outside tolerance, like a slower than expected retraction, the system immediately alerts the crew. Redundancy layers allow the process to repeat using secondary pumps or electrical backups if needed. Now climbing through thousands of feet, AI systems transition into cruise configuration. The flaps are retracted in stages, monitored by actuators that report movement angles to the flight control system. Again, this movement isn't just mechanical, it's verified, double-checked, and logged. The 777 times is now in controlled flight, but the brilliance lies in how it got here. No sudden motions, no abrupt transitions. Everything during the takeoff sequence is a product of harmony between human inputs and automated intelligence. What pilots used to manage manually is now done with layered decision-making, built to reduce workload and increase safety margins. To the outside world, this takeoff might look routine, but beneath that surface is a ballet of code, hydraulics, air pressure, and logic gates. It's a performance that plays out in less than a minute, but it's supported by millions of lines of software code, thousands of test hours, and real-time sensor fusion. And all of it happens in silence. Not a word from the systems unless something goes wrong. That's the beauty of modern aviation design. When everything works perfectly, you barely notice it at all. The Boeing 777 times takeoff is more than an impressive display of size and power. It represents a turning point in the evolution of flight. What once depended on human skill alone is now elevated by intelligence that never sleeps, never tires, and never stops learning. And that shift isn't just technical, it's psychological. Aviation has always been about trust. Trust in machines, trust in systems, trust in the people behind the controls. But trust also comes from predictability, from knowing that every takeoff will behave exactly as expected, regardless of weather, weight, or location.
Artificial intelligence is building that predictability into the very structure of modern aircraft, quietly and with astonishing precision.
When you watch the 777 times lift off the runway, you're not just seeing advanced engineering, you're seeing thousands of invisible systems working together to create something that feels effortless. That effortlessness is no accident, it's a carefully crafted experience, tuned to human expectations, smooth rotation, balanced climb, quiet, steady thrust. Every detail is designed to feel natural to the trained eye, and comforting to those who simply love to fly. AI is now a co-pilot in the deepest sense of the word. It does not take over, it supports, verifies, and refines. It helps pilots make better decisions under pressure. It reduces reaction time to milliseconds. It provides silent assurance that every system is behaving exactly as it should. But beyond the takeoff, this technology unlocks a new kind of possibility. The 777 times isn't just another aircraft. It's a testbed for future autonomy. While commercial aircraft today are still commanded by flight crews, the groundwork for reduced pilot workload, and eventually pilotless segments, is being laid now. This does not mean removing the human element. On the contrary, it means enhancing it. AI systems provide situational awareness far beyond what the human eye or even traditional instruments can offer. They detect patterns in weather, optimize fuel burn in live conditions, and maintain system health down to the component level, often before wear is visible. These capabilities are not just about performance. They're about efficiency and sustainability. The Genie Times engines, optimized by onboard analytics, burn less fuel, emit fewer emissions, and run longer between overhauls. Every adjustment made during takeoff, climb, and cruise adds up to fewer maintenance hours, lower operating costs, and a cleaner environmental footprint. In a world facing growing pressure to reduce carbon impact, these margins matter. For passengers, the difference is almost invisible. But for those who understand flight, for engineers, pilots, enthusiasts, the change is profound. The aircraft responds differently. It handles with less drag. It accelerates with more balance. It climbs with precision that reflects not just power, but intelligence. This is where emotion meets logic. The appeal of the 777 times doesn't lie only in its numbers or dimensions. It lies in what those numbers make possible. Long-haul routes that were once limited by fuel or noise regulations are now open. Airports once constrained by wing dimensions can now accommodate wide-body aircraft with foldable control. And future designs will borrow this same AI foundation to make even larger, more complex machines fly with ease. The deeper truth is this: flight is no longer about overcoming gravity alone. It's about mastering complexity. Modern aircraft are among the most complex machines humans have ever created. They move at high speeds, through hostile environments, carrying hundreds of lives. Every variable, from engine temperature to wind shear, must be monitored, understood, and adjusted for in real time. In the 777 times, this level of control is not only possible, it's routine. That reliability builds confidence, and confidence is what keeps aviation progressing. For the global aviation community, the 777 times stands out as proof that innovation is still alive in the skies. That even after a century of flight, there are still boundaries to push. For aviation lovers, it rekindles the original wonder of watching something so massive defy gravity, and do so with such elegance. But perhaps the greatest impact of the 777 times lies not in how it flies, but in what it teaches. Every flight gathers more data. Every landing refines the AI's understanding. Each rollout down the runway becomes another lesson, another line in the code that guides the next generation of aircraft. That's what makes this takeoff sequence so meaningful. It's not just the visual spectacle, it's the silent intelligence behind it. The algorithms making decisions at the edge of human capability. The systems learning, adapting, evolving with every rotation, every climb, every mile. What we're witnessing is not the end of innovation. It's the beginning of a new phase, where flight becomes not just mechanical or digital, but deeply cognitive. Where machines respond not just to input, but to insight. And that future is arriving faster than most realize. The Boeing 777 times takeoff AI sequence isn't just something to see. It's something to understand, something to remember. Because one day soon, these systems will be standard, and this moment will be known as the point where it all began.